Hey everyone. In this video, I want to kind of do a deep dive about Azure Key Vault, this secure resource in Azure where I can store secrets, keys, and certificates, and actually perform operations with it. As always, if this is useful, a like, subscribe, comment, and share is appreciated. Now, I do want to stress one thing right from the start. If I'm working with resources in Azure, many of those support things like role-based access control, very granular access, even at the data plane. So if I can, I want to try and use that role-based access control natively on services and trying to avoid using things like access keys wherever I can. But there are still times where, hey, I need a secret, I need a key, I need certificates. So let's actually start off first of all. What are we even talking about? I say secrets, keys, certificates. What do these things really mean? So I can think of a secret as basically something that is just some arbitrary collection of ones and zeros. There's no fixed format. There's no standards that are enforced. It's literally just a whole bunch of ones and zeros. And so when we think about that, what we really want to be able to do with a secret is, well, yeah, look, I want to be able to import that secret in or create the secret, but also be able to read it back out. So I can both write it and I can read it. So that's something we want to do. An application will go and grab it and then use it to do something. So this secret does kind of move around. I still want to try and protect it as much as possible. I definitely don't want it in source code. But it is shared. This thing actually gets read by the application and used by the application. So it can't just exist in some super secure enclave. Now that's super different when I think of something like an actual key. So when I think about a key, we are talking about something that has very defined standards about the format, about the randomness that is ensured for the generation of this. It can be symmetric or asymmetric. So remember, symmetric is where the same key is used, for example, to both encrypt and decrypt. Asymmetric is when there's a public and private key, and if the public key is used to encrypt, then only the private key can decrypt. Now that private key part, remember, is super secret. The public key everyone knows about. So when I think about keys, well, absolutely, we may want to kind of do an import or maybe a generate, but there is no concept of reading that back out. Now, what I will do is within kind of the area, I'm going to need to perform certain types of operation. And by operation, I'm really talking about cryptographic type operations. Decrypt something. Maybe encrypt as well, but typically the encryption is going to be done by the public key, so I can kind of do that anywhere. But only wherever I store that private key can do the decrypt operation. Maybe signing. Again, I sign with my private key, so anyone can then check that. So there's certain cryptographic operations I'm going to perform with that. And then I can think about, well, then there's certificates. Now, a certificate is really kind of the idea that, well, it's keys again, but they're wrapped in kind of an envelope. And so once again, with certificates, I can think about, well, yeah, I'm going to bring that thing in. Because remember, we have the private public key as part of that. So again, I can kind of import that, or I can generate a self-signed. But also, I can actually go and get that thing. I can bring that out because once again, this has that concept of kind of the public part, and it has the concept of that private in that kind of envelope. Now again, these keys could be asymmetric or symmetrical. So maybe there's public-private part, maybe it's just a single key. But what I want to do with certificates also is we kind of think about, well, the life cycle. And the life cycle could actually be, hey, I'm requesting that certificate from a third-party public CA. It could be renewing the certificate. It could also be kind of the distribution of that certificate. So I may actually go and interact with things like a public CA. I might go and distribute them to kind of machines. There are various actions I want for certificates. So now I think about, okay, well, what is this service? And those things I kind of just drew are all based around, well, this is what I want to do with Azure Key Vault. It supports secrets, keys, and certificates. And that's what its job is. Now, when I create an instance of Azure Key Vault, I'm going to create it in a certain region. So this here is, let's say it's in region 1. Now that could be East US, it could be West US, wherever that is, but the Key Vault is created in a specific region. That's kind of an important thing to know. And it's going to focus on those 3 types of data that I just talked about. So the easiest way to understand this is we could kind of go and take a look at this. So if I jump over to my Key Vault, and I can go to my Key Vaults, and I have 2. Now I'm just going to focus on kind of this second one for now. But actually, even before I did that, notice I can say, hey, I want to create a new Key Vault. And the key part is I give it a name for my Key Vault over here. I pick a region where I want to create it. And then there is a pricing tier, standard and premium. And they're really the options we have. It's the region and the pricing tier. Now you'll also see some other options. Soft delete is always enabled now. I'm going to talk about that later on. I can turn on purge protection, which we always recommend you do. And I can set a number of days for that. And then there's this access policy that, again, I'm going to come back to. But there's really not a lot I do. Hey, give it a name, a region, and the pricing tier. Now, once I've actually done that, I'm going to come out of this, we can see we basically break it down into those 3 types of object: keys, secrets, and certificates. And if we look at keys, for example, well, I've got kind of a key here. I can select that key. I look at it. And notice I can download the public key. There's that kind of button up here. I can get a pen file with the public key. But I can't get the private key. There's no way for me to go and extract the private key. Because keys, again, I can import them in or I can generate them in Azure Key Vault, but I can't get it back out. The private key is considered this super, super secure thing. I do not want to leave the boundary of Azure Key Vault. Now, I can generate import one. Like I say, it can actually do a generation. I can select the key type, RSA or kind of the elliptical curve, the key size. I can set expiry dates, which is a good practice for these types of things. Or I can import, or I can restore a backup. So an import would be, hey, I've generated this using some secure technology on premises. And then there are, again, technologies to actually securely import those into the Key Vault. I give it a name and it would generate a new key for me. Then we can think about secrets. Well, again, a secret is all about, well, it's something I store, but also I can just read it back. You notice here I have this option to, hey, show me the secret value. So if I touch that, there it is. Secret value is password. So it's storing it securely, but I can go and fetch that thing back out if I want to. And then there's certificates. So again, I've got this self-signed cert. Now the way this generally works is for the certificate lifecycle is it can actually talk to certificate authorities. And there are, I think, 2 key ones kind of supported today, DigiCert and Global Sign. So when I do this, it will actually go and do things like, hey, request a new certificate, automatically renew it for me. And then, again, it can help with kind of the distribution. But here on my certificate here, you can actually see, hey, there's issuance policies around it. I can go and look at this. And I can actually download the certificate. So I can actually go and get the private and public key of the certificate. So that's all available to me. So I've got those three key types of object. So certificate management is all about that birth to death of the certificate authority. That's kind of the key point with that. Now you also would have noticed for all of those things, there were versions. So you notice when I looked at the certificate, there was versions. The keys, there were versions. Secrets, there was versions. That's not really native to any of the types of data. That's really just Azure Key Vault forms a relationship between, hey, I can create a new secret, or call that a new version of this particular one. And it helps with applications so that I can kind of rotate nicely, and that older version is still there to carry on being used until it rolls over and use the new one. So we have this concept of versions. Hey, I create a new version of the secret. Maybe I want a new password. Hey, I want a new version of the key. Every 6 months, I rotate the key, for example. So we have that version concept. Now you saw when I created the Azure Key Vault, there was the concept of standard and premium. And maybe the easiest way initially is if we look at the pricing. So if I look at the pricing details of Azure Key Vault, so you can understand what the difference is. It really boils down to one thing and one thing only. You can see standard and premium. So secret operations, the same. Certificate operations, the same. Okay, that's weird. Software protected keys are the same. HSM protected keys, standard, not applicable. Okay, but on the premium, we now have this idea of the HSM backed service. So the key point with this is that for standard, it's all software-based protection for my Azure Key Vault. So we talked about these kind of three types of operation. And so then I can think about, well, there's kind of this standard tier, and I can think about kind of, let's bring this in a bit, a premium tier. Now, no matter what tier I'm doing, the key point here is really, instead of standard and premium, I could almost write software and hardware. So here, standard is always going to be software protected, as is the premium. So what I can actually say here is, well, I'm going to write premium as well, because premium does actually use software for certain things. But then premium can always also use the HSM for certain things. But only premium has access to HSM. Standard and premium have access to software. So secrets are always stored in software. So whether I'm using standard or premium, secrets are stored in software. Whether I'm using standard or premium, certificates are always stored in software. Now, for keys, both standard and premium can store in software, but only premium has also the option to store it in HSM. So remember, HSM are these security modules that actually use hardware to protect and perform the various cryptographic operations. So when I perform something like a signature, it's done within the hardware. That key never leaves the boundary of that hardware. So this is only premium. I cannot use a HSM in a standard type of account. So that's kind of the huge difference between them. Premium lets me have the option of creating a HSM-backed key. And so it's going to cost me a bit more money. If we go and look at this for a second, so let's look at my vaults. So this vault, my Savile Vault RBAC, when I look at the pricing tier, notice the pricing tier is standard, which means that I can only do software. So when I create a key, My options are RSA and EC. That's all I can do. If I go and look at my other key vault, we can see the pricing tier here is premium. So now when I create a key, notice I also have two additional options, -HSM. So these will actually now store and generate that inside the HSM and do the cryptographic operations inside the HSM. And that is literally the only difference between them. I have that option to have that HSM protection when I maybe need that even higher assurance of the security. I want to go beyond just software. Now there is actually a kind of third option. So I'm going to draw a terrible line right here. If I kind of think about these, there's also, that really is a terrible line. There's also a managed HSM. So the managed HSM, what this is basically doing is, so remember with premium, I can still create secrets and certificates in software. I still have the option to create keys in software. But I also have the option to create HSM-backed keys. With a managed HSM, I can only create HSM-backed keys. So this is only. I cannot create, if I create a managed HSM, I cannot create secrets, I cannot create certificates, I cannot create software-based keys. I'd have to do a different vault for that. And what's happening here is this managed HSM is actually, let's get a bit bigger. So this is a dedicated HSM partition. So within the physical HSM constructs, it actually supports partitioning. So think of this as its own security world. It's completely isolated from any other. Also things like confidential compute enclaves are leveraged as part of these solutions. So if I'm thinking, hey, key vaults, and maybe I need to go even another step with the HSM, there is this concept of a managed HSM as well. But for most of us mere mortals, we're going to focus on kind of those premium and standard. And again, the only difference is premium can also create HSM-backed keys, but it doesn't change anything about the way I interact with it. Now, I guess there is one other thing you can do, technically speaking, with the managed HSM. For these keys, these are all asymmetric. It's using RSA or EC, as you saw, the elliptical curve. So both of those are asymmetric algorithms, public-private key. Managed HSM does also add the option for AES. So AES is a symmetric algorithm, the same key used for encrypt and decrypt, etc. So if I do the managed HSM, I'll get an additional option where I can actually use AES as well. Whereas these are all kind of RSA or EC, as you saw when I kind of showed that example. So that's kind of those key differences between them. And you can see which one I want. I'll pick the various one. Now, I talked about versions already. But just to show that super quickly, if I go back over to my Savile Vault RBAC, and I can kind of look at my key, which is just a current version. But I could absolutely say, hey, I need a new version. I say I want you to generate it and create. And that's it. And if I refresh, there, I have a new version. But the old current one now becomes an older version. I can do exactly the same thing with secrets. So if I looked at my secret 2, here's a current version. I can create a new version of the secret. And I put that in. I can put a content type. I might just say, I don't know, You don't have to put that, or I could make that a requirement. I might say, I don't know, it's a password or something. Create. So now once again, I have a new version. So I could look at that, and I can see, oh, it's a newer secret. And then the older version was still there. That was another password. So I have this concept of versions as things change, as I kind of rotate those things around. Now, one of the things that can happen, and this is where we start talking about some of the configurations, is obviously I can delete these things. I could delete a key, I could delete a secret. And the whole point of these things that I'm having over here is they're going to be used for things like a secret. It's access to something. A key, I might be using that to encrypt something. So imagine I'm using this key to encrypt a storage account, and then I delete it. That's a pretty bad day for me, because now I've not just lost the key, that key was used to encrypt the data encryption key that encrypt blocks of data in my storage account, and I've now lost it. So there are two key settings we think about. The first is soft delete. So this means, hey, when I have soft delete turned on, even if I delete it, I can restore, I can get that back. So we always want kind of this soft delete option turned on in our environments. And then the other thing is something called purge protection. Purge protection basically says, hey, it doesn't let me purge things I've deleted prematurely. So otherwise I could say, if I was malicious, I could delete it, and even if soft delete, I could then go and purge it quickly. So when we look at our key vaults, I'm going to come to this when we talk about best practices. Well, I'm going to focus on this a little bit more. But on your key vault, you'll actually see you have this concept of soft delete and purge protection. And these are one-way operations. Once I turn these on, I cannot turn them off. So if I look at soft delete, well, it's enabled, it's 90 days, and I cannot change it. I've also got purge protection turned on. I cannot change that, and I cannot turn it off. And the default now is, you kind of saw it, when I create a new key vault, I can't select to not have soft delete anymore, but I can opt not to do purge protection. My recommendation would be kind of always turn that on. You really do want that. See, I've got that on both of mine. So those are very useful technologies to really help protect you from yourself or bad people doing things in your environment. So now let's talk about, well, how do I control access? We've talked about, well, these things are super important. I'm encrypting data, I'm signing things, it's validating I am who I say I am. Well, I need to make sure only the right people, the right applications can actually access it. And there's actually two ways to kind of control access to things. I can actually think about, I don't want to use red because that's something bad. We'll do purple. So we have the concept of access policy. Or, I'm going to do this in green. Role-based access control. And from my colors, you can kind of guess which one I'm going to kind of favor on here. So access policy was the original. And the issue of access policy, I'm going to give this one a little star because we like this one the best. It applied to everything in the vault. And what it would basically let me do, and let's just look at this, is I could only give permissions to a type of object. So this is my Savile vault over here. If I look at access policy, you can see my mode is vault access policy. And what we see here is I create access policies. So I can say, well, here, user Clark Kent, or it could be a service principal, it could be a managed identity. I give it permissions to the three types of objects, keys, secrets, and certificates. Those permissions apply to all instances of secrets in this vault. I cannot be more granular. I cannot give Clark access to 2 secrets, but not others. So if I wanted that kind of granularity, I'd have to create multiple key vaults. So that's why we prefer the new model with role-based access control. You can see now those policies have just gone. So now instead, I can set things at the Vault level still. I could give someone certain roles at the Vault. So like me, I'm a Key Vault administrator. Clark Kent can read the objects, but not actually get access to the data plane from there. But then I can dive into detail and see, well, for secret 1, it has its own access control. And I can see, well, secret 1, okay, well, Bruce Wayne over here has Key Vault secrets user. So Bruce Wayne can use that secret, i.e. get it to actually use it. Whereas for secret 2, this time the Key Vault secrets user was actually 2 here, okay? But I can see a function has access to it, and so does Clark Kent. So I can see Clark Kent actually has access to this one. So it's granular at that kind of item level. Just checking something here a second. There we go, okay. And you notice actually on this one, there's this weird demo VM has Key Vault secrets user for secret 1. And I'm going to kind of show that in a second. So here I've got a different session. This is actually logged on as Clark. You can see here in the top right corner. So Clark Kent, because he's got Key Vault reader, well, Clark can see everything. Clark can see there's 2 secrets. I can go and look at secret 1. But hey, this operation is not allowed by RBAC. I can't see the current version, and I can't do it. I can't get access to the secret values. I don't have permission. Whereas, if Clark looks at secret 2, remember, on secret 2, Clark has, at an item level, that Key Vault secrets user permission. So on secret 2, I can look at the current version. I can actually see the value. So we have this super granular set of permissions to say exactly what can be done. So generally we're going to use that. I don't really want to have a ton of separate vaults if I can help it. Now I could give different apps permissions at individual secrets, individual keys, individual certificates. I now have that capability. Okay, that's good for a user. Most of the time, these are not users leveraging these things. Most of the time, I'm going to have a resource. So I can think about, okay, well, I have a resource in Azure. Now, that could be a virtual machine, a function, something. And so the best thing I can do here, if I can, is you get a chicken and egg problem. Because I have to be able to authenticate to Key Vault. Well, if the password's in Key Vault, how do I prove who I am to be able to get access, to authenticate, to get access to the secret? So we solve the chicken and egg problem by resources in Azure can use something called a managed identity. So this is kind of a native Azure feature. So just by being that resource, I can turn on this managed identity system assigned, where it's just automatic lifecycle tied to the resource, or user. It can be shared by multiple resources. So now that managed identity, I can give permissions via RBAC. I could have done access policy as well, but again, we don't want to do that big generic thing, to certain secrets. So it will authenticate as the managed identity, and I give the managed identity permissions through RBAC. And we can see that. So if I jump back over, remember, on that other secret, well, we're looking at right here, this secret 1, remember, demo VM. Interesting. So what I did there is I did add role assignment. My role, I want them to be able to access the secret. So it's a Key Vault secrets user. And then I selected, well, it's a managed identity. And I selected my VM. and I selected my virtual machine. Now again, that virtual machine is nothing special at all. I just, on that virtual machine, turned on its built-in system assigned managed identity. Now what that means is from that VM, so if we jump over, actually before I jump over, I'm going to copy one little bit of code because I'm lazy. So if I have a managed identity, I can actually just authenticate as that identity. I can do connect AZ account - identity, use my built-in managed identity. So I can take that, actually we'll take all of this big block of code because I'm very lazy. And if we jump over to here, and just to save that code for a second, I'm just going to paste that. So the first thing we'll actually do is let's actually authenticate in this window. So I want to use the managed identity. Oh, it's not working. So I'm trying to be lazy. Let's try it one more time. There we go. So we can see it's authenticated, and I didn't give it any credential, but it just authenticated as its kind of self. It's this MSI. So now all I'm going to do is from here, I'm going to take this entire piece of code. Now what this code is fundamentally doing is, it's really the first line is the important part. So this first line is saying, hey, get the secret from the Azure Key Vault. So if we just paste that one line, notice it worked. Now let's prove a point, because remember I only gave the managed identity access to secret 1. If I try and get secret 2, it fails. I do not have permission. So the managed identity only has permission to secret 1, but now, and this basically just takes a secure string and shows it. That's all this block of code does. So now I can just paste all of that in, and there's password. So that shows, hey, if I'm an Azure resource, fantastic. I'm just going to use managed identity and then give the managed identity if I still need access to some secret or something else. Now again, remember, if I have managed identity and I'm accessing an Azure resource, in an ideal world, I would just use RBAC on whatever that target resource. If it was a blob storage account, I can do data plane RBAC. So I would just give the managed identity direct access at the data plane using role-based access control on the target resource. I don't want to mess around with an access key or something else. But maybe I can't. It's a resource that still uses an access key, or I need a key for something else, or I need a secret. I would secure it with that managed identity. So that's great. But what about then if that's not the scenario? What about if I'm something on premises and I'm a resource, and once again I still have that challenge that I have to authenticate. I have to auth to Azure Key Vault before RBAC will kick in and say, okay, well you're this person, then you have access to these things. Managed identity is easy if I'm in Azure. If I'm on-prem, you're really back to a service principal. There's really nothing else for it. So this is where I would have a service principal. So remember, a service principal is something I create in my Azure AD, and I'm going to authenticate either using a secret, i.e. a password, or it's going to be a cert. A cert is preferred. But realize you're back in that kind of chicken and egg scenario a little bit here. So I'm running my code on-prem. I'm going to use this secret or this certificate to authenticate to Azure. Where am I storing this? I don't want to put it in my code. I don't want to put it in my config file. So now I'm really back to the idea that, and obviously I can't store it in Key Vault because I have to authenticate to Key Vault to get this stuff out. So one of the things now you're back to is, well, on premises, I need some local kind of vault technology, ideally, where I could store these things securely so they're not in my code. And there are various solutions out there for this. I know HashiCorp has them, PowerShell has kind of this idea of a secure store now. But think about that. Under no circumstances, like stick it in your config file or your source code that then goes and sticks into GitHub or Azure DevOps or something, and then you have a bad day. But the whole point of all of this is this RBAC gives me this granular set of permissions, which is fantastic. So this is why we want to do this. But just realize, hey, I have to authenticate to Key Vault to get access to the stuff. So you're going to have a service principal. Now, I did a whole video on kind of unattended authentication to Azure. My demos are based around PowerShell and a storage account, but exactly the same thing would apply here. So go and look at that video, and I walk through using a managed identity, I walk through using a secret, and I walk through using a certificate. So you definitely kind of want to use that. If you're using Azure Arc on premises, so Azure Arc is the idea there's kind of Arc for servers. It's bringing the Azure manageability to on-prem. So the Arc for servers has a local managed identity concept that's just automatic, and it can be used to go and authenticate to things like Key Vault. So if I'm using Arc, potentially, hey, Arc has a managed identity concept. So maybe I can use that if I'm doing that kind of Arc for servers. So you could definitely maybe take a second and go and look at that. The only other thing when I think about permissions on my Key Vault itself is if I'm using the Key Vault for things like ARM templates or data encryption sets, I have to say, yes, I'm allowed to do those things. So on my Key Vault, my access policy, you see these, hey, enable access to. So if I want to use it for things like BitLocker, for just regular, hey, I'm using it for an ARM template. If I want to use it for a disk encryption set, the ADE, then I have to kind of turn it, sorry, not disk encryption set, for the Azure disk encryption, like the BitLocker stuff, I have to turn these on, or those resources won't be able to actually access it. So it kind of talks through, hey, look, here, VMs are permitted to receive certificates, are allowed to retrieve secrets, is allowed to retrieve secrets. It's for kind of the wrap and the unwrap. So make sure you turn those on if you're using those various types of options. So that's all about permissions. Okay, great. That's about, hey, I'm authenticating and what I can do. And I'm kind of drawing these lines to access kind of the data plane of my Key Vault. What about actually the connectivity to it? So I can think that, yes, there's like all Azure resources, there's controls on the service. And it really is in common with all of the other Azure services. I can kind of restrict to certain IP addresses. I can restrict to service endpoints. Remember, a service endpoint is where, once again, I'm kind of a resource in Azure, and I'm a certain virtual network. So that's a VNet. And then I have a certain subnet. So a service endpoint is when I make that subnet, I turn on the service endpoint for Key Vault, and it makes it a known entity. So kind of subnet 1. And I can say, hey, yeah, subnet 1, I'm going to let you come through. And I get kind of this optimal route. I can also do private endpoints. So remember, private endpoint is when I basically project. So once again, I can think about here, if this is kind of Azure Key Vault, a private endpoint creates an IP address, I'll just say private endpoint, inside that virtual network I specify. And there's special DNS entries I add, but now I'm accessing it via this IP address, so I can really kind of lock that down. So if we go and look, I just go and look at my networking, and right here I can say, okay, I could add certain IP address ranges. These are public-facing IP addresses I want to be allowed to access. I could add a virtual network. Now again, the way a virtual network works is a service endpoint. If I just quickly went and looked at some of my virtual networks, look at this one, and I looked at a subnet, you can see all my different subnets over here. Notice I can turn on service endpoint. So here if I type in key, there's Key Vault. So I could enable Key Vault service endpoint for this subnet. Now that just makes it known, it doesn't give it permission. So then once I turn on the service endpoint, and I don't technically have to do it in advance, it will actually do it for me in one go. But then I could actually go to my Key Vault itself, and then I can say, hey, I want to add an existing virtual network. And what subnet do I want? And basically it's going to say, hey, look, I didn't turn that on, but it will offer to create it for me. So now I can actually go and add that subnet. So only things in that subnet would be allowed to actually come and talk to me. Or I could lock it down by private endpoints. I could go and create a private endpoint in a particular network and restrict access to only things coming from that private endpoint. So that would be kind of an option for me as well. So I have all of those different ways I can think about controlling access into my Key Vault. So we think the two different levels. We think about, yes, kind of the granular role-based access control and on who the person is, that RBAC. And I can think about controlling from the network perspective and that traffic actually coming in. So from that network access perspective. This is all great. Super granular, controlling the access on the network, all these great types of things that exists in a region. What if something happens to the region? And so what happens is, remember in Azure, regions are paired. So there's this built-in pairing of regions. Now I don't get to pick these, but there is a pairing of them, just native. You can go and look these up. And what is happening here is this replicates to the paired region. Again, I cannot pick a different region, but it is going to replicate to that paired region. And if we go and look at the documentation, let's look at this. This shows me what the paired regions are. So I can quickly kind of see, okay, well, based on the regions, what are the various pairings within them? That's where it would actually be. Now remember, the Key Vault is not restricted to the local region. So even if something happened and it failed over and I was trying to use it in a different region, I can still access this. If something happened to this region, the DNS entries are automatically updated and will redirect to the paired region. I don't actually have to do anything. But what about if I want to do a backup? Remember, certificates, I could just write my own thing to fetch it and write it somewhere else. Certificates, I can fetch it and write it somewhere else. Keys, I can't. I kind of focused on public, private here. Remember, there's, depending on if it's symmetric or asymmetric, there's public, private there as well. I can't get the private key. There's no way to get that out in a format I can do anything with. Well, that's not strictly true. So one thing I can do is I am allowed to back up. So I can create a backup. Now that backup can be restored. Now where can I restore it? So I can restore it to any region in the same security world, which really in most cases basically means the same country. So it's anyone in the same country, the same security world. So if I was in East US, I could restore to West US, but I couldn't restore to Europe. And the way I can see what those are is if you actually go and look at the Azure regions, there are tabs. And the tabs represent those security worlds, those countries. So if I actually look at this for a second, let's have a quick look. So firstly, we can see the documentation that talks about that restore. And the restore tells you, well, it has to be the same subscription and they have to be the same geographic location. Okay, so what is the same geographic location? And the geographic location basically boils down to, it's saying the major headings in the tables. Those are the security worlds. So if I go and look at Azure regions, the major tabs are United States, Mexico, Chile, Canada, Brazil. If I was to go and look at, I don't know, United Kingdom. So I could only back up and restore to these. That's the key point. I could not back up from Germany West Central and restore it to United Kingdom. It has to be the same security world. So that's kind of the key point. If I want to use kind of those built-in capabilities, yes, I can back up and restore, but I have to back up and restore in the same security world. Because of the way behind the scenes, when you do that backup, it's encrypted so that only something in the same security world actually can decrypt it. So I'm saying the same country here, but the point is it's the same security world. That is kind of the big feature. It's the same security world. So I can back up, I can restore. So anywhere in the US, I could back it up, restore it somewhere else. I can absolutely do that. Now I also mentioned that, hey, I can access this Key Vault from other regions, but realize some resources, they want the Key Vault in the same region as the resource, like a storage account. It wants the Key Vault in the same region. SQL, Transparent Data Encryption, TDE, wants the Key Vault in the same region. There's latency, there's controls around that. So for some services, like SQL is a good example, I can have asynchronous read replicas in other regions. And if you follow the guidance, it will talk about, hey, yeah, you need to create a Key Vault in every region I have a SQL async read replica. And it's kind of my responsibility to make sure the same key material is in each of the Key Vaults. So in that case, I would probably create the key locally. And I would do that as kind of secure import into the Key Vaults in all 4 of the regions if I had 4 async read replicas. So that would be my responsibility to do that. So that's kind of a key point. Another good thing to use is Azure Policy. We talk about Azure Policy all of the time as a way to kind of set guardrails, set these controls. And Key Vault is no different. If we actually go and look at Azure Policy, there are a mass of great things we can actually do. Now, I talked before about kind of different algorithms and key lengths. I talked about how long something should last for, expiries. So if I go to Policy and look at my definitions, if I change the category, let's unselect everything, and we just look for Key Vault, there is a mass of different things about Key Vault. Now, there's some obvious ones. Hey, I should have purge protection enabled. I should have soft delete enabled. Yes, 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 all day long, yes. I can turn on things like, hey, I should have a private endpoint. But what I'm interested in are things like, hey, look, certificates should have a maximum validity. There are allowed key types. Keys should have expiration dates. Keys should have, secrets should have maximum validity. So I can go through and actually all of these different things. Hey, look, keys using RSA should have a specified something. Let's see what that is. RSA should have maximum key size. So I have all of these options that, hey, I can really control what my Azure Key Vault should look like. I can lock all of those things down to make sure it is exactly what I want it to do. So go through those. You have policies in your organization. I'm going to start using Key Vault. Work out what your policies are. Be able to write them down. And then I can use Azure Policy to actually think about enforcing them. So really make sure, I'm not quite sure where to put it on this picture. I've got so much stuff on here. But kind of use Azure Policy. I'll just do it in kind of the always add Azure Policy. We want that at the ARM level, so no matter what we're doing, PowerShell, it doesn't matter what, it's going to enforce those things for kind of that governance. So with that said, I talked about kind of best practices, and I just wanted to kind of go through a few little things when I think about really ways to use this and kind of avoid getting in trouble. So best practice. So rule one, funnily enough, back up your keys. And by saying I'm saying keys, but you want to back up everything you have. Now you might say, why am I doing this? Remember, Azure's already replicating it. And honestly, if you have soft delete and I have purge protection turned on, I'm in a pretty good place because I'm pretty protected. So as long as I have kind of that soft delete and I have purge protection, as long as I've not got silly values, I should notice something's amiss before it impacts me in a negative way, and I should be able to bring them back. But the reason we're doing this is really for two key reasons. I can think about, well, it could be an insider mistake. Someone's not focusing, and they delete the key, they delete the secret. My mistake. Whoops, wrong button. I wrote a script that wasn't very good. I left off what if, and I've wiped away, and I now can't get to my storage account. With these things, I could just restore it anyway. Or it could be a malicious insider or attacker or whatever that could be. And again, this would protect me from that to a certain degree. But if I have a backup of the keys, it really just helps me. So I think about, hey, definitely these are best practices. Have this soft delete turned on. Make sure you have purge protection turned on. Again, that soft delete is all about, hey, I'm soft delete for X days, whatever you have that to. I think 90 is the most. Have that turned on, but make sure you kind of back up those keys. It's good to have that. I would think about, make sure you use RBAC. So I want to use role-based access control. I don't want to do those vault level. And make sure you're kind of doing least privilege. Don't give people access to more than they need. Don't give them rights beyond what they need. Just individual secrets. And the nice thing here is with the RBAC, I can use things like MFA. I can hook into things like conditional access. I can do those same things to kind of lock down and control. And if I'm using RBAC, I can also use PIM. So remember, PIM is that privileged identity management, i.e. just in time. So maybe I'm sort of some administrator with heightened permissions. Well, I have to elevate up before I get the permission, and then I can do the various things. So I think about using that. Make sure you've got audit logs turned on so I can see who is doing what. So I want my audit logs. That's kind of super important. Again, that's diagnostic settings, and I can send it somewhere. That will also give me things like insights as I go through. And I guess if I'm writing my own custom applications, the idea of having kind of primary, secondary credentials so I can rotate them. So again, this is more about my apps. Built-in stuff is going to do this automatically. But think about the idea of a primary and a secondary. Because then, hey, I can be using one, I can rotate the other, then my app can switch to using the other one. It just makes it much easier for my application to actually use. So there's some of the things that I would think about for my application. Now, there are limits to Key Vault. If we quickly go and look at the limits, but I mean, they're huge. I would not really anticipate they cause you a problem. So here I can see, here are the key types of transactions I can do. So HSM key transactions, 1,000, 250, 125. This is every 10 seconds. Then the software keys. So this is about keys. And then for secrets, other types is 2,000. That's a lot. So 2,000 every 10 seconds. You really shouldn't be hitting those limits. I mean, the way you're going to write your application is For most things, you're not constantly going and getting this from the vault every time you do something. You might go and get this, it's stored in memory or something, you're using it, you're unwrapping something. So, but just be aware that there are limits to what I can actually do and how I can use them. Which brings me to really one final thing. And that's really about using those for rotation. So I talked about things like, oh, this primary, secondary key. And then many services in Azure actually use Azure Key Vault, or they might use like this internal bootstrapped version of Key Vault that removes some dependencies, so it's kind of more available for some of the startup scenarios. So with services in Azure, many of the times I can do like a Microsoft managed key, which is where it might use Key Vault, it might use this bootstrap version, or I can use a customer managed key. So with that resource, I can think about, okay, because we want that encryption at rest, so I have some resource, and I really want that encryption at rest. So once again, I can have the idea of kind of the Microsoft managed key where I don't really do anything, or I can have this kind of customer managed key. And again, that key is going into Azure Key Vault. And you can see this if I go and look, for example, at really any service there is. But if I just pick a storage account, for example, I can do my encryption. You can see I'm using a Microsoft managed key, but I could change it to a customer managed key. If I select that, it's going to say, oh, okay, well, it's from a key vault. Which key vault is it in? So I'll say, okay, it's in that key vault. And it will either say, hey, use a key you have, or I can create a new one. But that's now in my key vault. And pretty much all of the services are going to give me that same option. Now the issue then really becomes, okay, that's great. What about the rotation of those things? So it's now my responsibility. I've said, hey, I want to manage that, but I have to rotate it now. So this is a huge thing that I am responsible for. Now remember, I can use things like Azure Policy to remind me. Remember, I can set those policies about kind of lifetime, how long it can last for, the key durations, all of those things. So it will say, hey, look, you're coming up to this point, you need to rotate this. And what really my focus here is, be aware different services do different things. Some services, hey, so I have my key. So I've got this key, customer managed keys in the Azure Key Vault. So fundamentally, I have a key. And remember, we have versions. So I, as the person, can say, hey, new version. That could be generating it, it could be importing it, but I've created a new version. Now, different services will behave in different ways. Something like Azure Storage. Things like actually now data encryption sets, which are used for managed disks. They will just automatically see it. So they will auto see there's a new version, and roughly 1 hour switch. I don't have to do anything else. SQL Server is different. SQL Server, because I might have those async read replicas in different regions, I need the same key material. After I rotate to a new version, I have to do something. So something like SQL today, and this could change, it's manual. It is not going to say, hey, there's a new version, I'll start using it. I have to say, okay, I'm going to go and use this new version when I click this button. And the way you can generally tell, because there's like 70 odd different services that use this. The way to generally tell is when I do the configuration. When you do the configuration, you have to tell it the key. So you're saying, hey, I want to use this key for the encryption. When I tell it the key, if I don't have to say a version, then I'm going to expect it to be automatic. I create a new version. That service, I didn't tell it a version to use. I just said, use that key. Within some time frame, an hour is pretty typical, it will just see the new version and start using it. So this is the config of service. So this could be, again, an Azure storage account. This could be an app service. App services can now just point to a secret or what a key, whatever that is, and we'll just automatically go and get the new version now. Didn't used to do that. If I have to say a particular version when I do the configuration, then it's going to be manual. Hope that makes sense. If when I'm configuring the service to use a customer managed key, and I have to tell it a particular version of the key, then when I create a new version, I'm going to have to update it to now use that new version I've generated. If when I configure the service, I didn't have to do that, and I just said, hey, use this key, when I didn't say a version, well, it's responsible for going and getting the version and doing that auto rotation. I still have to create the new version of the key, but I don't have to go and tell the service to start using it. It will just kick in at a certain point. Azure Storage is actually an interesting one. Azure Storage also has the idea of the access key, which is kind of those two keys that give me global access. That can actually be stored as a secret in Azure Key Vault. There's actually kind of some extra stuff that will automatically go and rotate the storage account key on the storage account and store that new version as a secret in Azure Key Vault. It's kind of an add-on thing, but that's not the encryption at rest. The encryption at rest is done using the key. That's kind of the key point for that. But those are really the key things I wanted to kind of point out for this. So Azure Key Vault, kind of super powerful. I can have those 3 different types stored within it. Use role-based access control. I can control the network access through things like service endpoints, or I can use private endpoints. It's going to replicate automatically to the paired region, but I can back up and restore to any region in the same security world, i.e. the same country. I do have to authenticate to the Key Vault to get those things. So if I'm a resource in Azure, again, ideally, I just use my native managed identity and use RBAC at the data plane to the resource. But if I can't, if I still need a key or a secret or something else, then I can use the managed identity to authenticate to Key Vault and then use the RBAC on the managed identity. On premises, if I'm using Arc, maybe I can leverage its native managed identity. But for most things, I'm going to need a service principal in my Azure AD and then use a secret or certificate. But then I have that chicken and egg problem. I'm going to have to store that somewhere locally to then be able to authenticate. Remember, there is the standard and premium. Premium, the only difference is I can have HSM-backed keys. Hardware, always in the hardware. These are asymmetric keys, public, private. There is the managed HSM as well, which adds asymmetric, the AES. Went through some key best practices. Back up your keys. Use that RBAC, the least privilege. Turn on audit logs, primary and secondary. And then if I'm using these keys for kind of customer managed key for services, basically, if it doesn't make you select a version, it's going to automatically pick up when it's rotated for me. If I have to say a version, hey, it's going to do that. And I had one little demo. I figure I'll just show it super quick. So all I'm going to do in this is I'm actually just going to show you encrypting and decrypting something. So what I'm going to do first of all is I need a token for myself. So what I'm going to do here is I'm going to get a token using my current context for the audience vault.azure.net. So that's going to actually create me a bearer token. I'm going to create an authentication header with that token in it. And then all I want to do is encrypt something. So what I'm going to do is encrypt the word hello world. So basically I'm going to create an encoded version of hello world. And I'm going to say, hey, I want to encrypt with the RSA 1_5. Now remember, when you encrypt something to someone, you're encrypting with their public key. So then only they can read it. Technically, I don't have to use Key Vault for this. I could just do this anywhere, but I'm being lazy. So I'm going to use the encrypt version of the Key Vault and the public key here to do the encryption. So I'm going to use a web request to my vault and to my signing key. And I'm actually specifying a particular version of the key. So I'm going to send that. And I can look at the headers, I can look at the content. But fundamentally, I've now got an encrypted version of Hello World. So that's kind of that encrypted version down the bottom. So now what I'm going to do is create a new body with the value is now that encrypted string. And again, we could look at that encoded hello. So hello world just looks like that. SGVS. The equals is a padding. You always get these sets of 3 characters. So it's kind of padding it with that equals. So now I'm creating a new body with that encrypted value in it. And now I'm encrypting it using the same key, but now it will use the private key. But now I'm asking it to do a decrypt instead of the encrypt. So I'm sending it. And what I got back now is I can actually just quickly look at what it sent me back. Notice it doesn't have the trailing equals. It doesn't put the padding in for me. So I'm just adding a pad equals. And then that's it. Now I just need to convert it from a base 64 string and hello world. So you basically saw me there very quickly, but I kind of wanted to just show it for a bit of fun. That was just me using the Key Vault. Again, the encryption, I encrypt with someone's public key. I didn't have to use Key Vault for that. It puts it there as it's being nice, but I don't have to. Now, if it was AES and it was symmetric, then I would definitely have to use that to do the encryption, because that's where the key is. But what you saw me doing just here is, hey, I sent to the Key Vault, hey, encrypt this for me. It spat out the encrypted text using the public key. And then I sent it the encrypted version in saying, hey, decrypt, so it uses the private key. And it gave me the value. So that was using kind of just a REST interface. Super easy to get a token for that, as you saw through the PowerShell. It's in the GitHub repo that I link in the description. Just wanted to end on something fun, just showing the Key Vault actually encrypting and decrypting something. So that was it. I hope this was useful. Until next time, take care.